All right, Crewton Ramone's House of Math. We'll probably pan a little that way. Oh, jeez. There you go. It's supposed to be right angles and stuff, but oh. All right, so let's see here. What was we'll start. What are we gonna do? We're gonna start at 10 or 9. Start at 9 just for fun.
Start with 11.
You started with 11. How about 9, 10, 11, 12, 13, 14, 15? Oh, we only got to 14. All right. So let's see here. That's 81. That's 100. That's 121. That's 144. That's 169. What's 14 squared?
196.
Got it. All right. So that's x. That's x squared. And x cubed. What's 9 cubed?
729.
Got it. And then that's obviously 1,000. All right. Now keep going. Ooh. 121 11 times.
1,331.
1331 is correct. There's a. Have you seen the? We should do that Pascal's triangle sometime. For doing 11s. Anyway, with 12s.
1728.
1728. This is a pretty. What number is that?
That's 12 cubed.
It's 12 cubes. So what is that? That's a square. That's a cubic foot, right? 1728 is the number of cubic inches in a cubic foot. Alright, so if you have a box that's 1 foot by 1 foot by 1 foot, there are 1,728 of these. If you were if this was a 1-inch cube, and it's not, but if it was, there would be 1,728 of them in that cube, right? 144 12 times.
Mm-hmm.
Right? So, and then if you want cubic yards, multiply by what?
I'm not sure.
Well, how many feet in a yard?
There's 3 feet in a yard.
There you go. So,
Multiply by 3.
really? You're going to multiply inches by 3 feet? No fun, get back to 1. Everybody got to be the same. How many inches in 3 feet?
36.
Okay, there you go. See, this kind of logic and reasoning you got to be able to do. All right, so then you got to multiply this number by 36, right?
Mm-hmm.
Does that work?
Yeah.
Okay. Let's see here. How about 13? Once again, 13 cubed.
2197.
See, like I said, these are just numbers that you should have met before, not completely strangers. 2197 is in fact 13 squared, or excuse me, 13 cubed. What's 14 cubed?
2744.
2744. All right, so there are your 9 through 14, and just because I should take a screenshot or something. Just zoom out just a little bit more, and then I can take a screenshot. Because I don't have that. All right, can you see that? Yes, you can. All right. Okay, so then let's see. So that's 9 through 14. Keep going. So what do we do? 15, 16, 17, 18, 19, 20. So let's see here. What's 15 squared?
225.
Got it. What's 16 squared?
256.
17 squared?
289.
18 squared?
324.
And 19 squared?
361.
Got it. Alright, now cubes.
15 cubes. 3,375.
How much?
3375.
There you go.
4096.
And isn't that vaguely interesting? And it ends in 75 instead of 25? Might do a lesson on cubing numbers that end in 5, but not today. Alright, so 16.
4096.
And
4913.
very odd number. But very odd number. Keep going.
5832.
And
5859. 68.
just for fun, what's 3 plus 6
9.
plus 1?
10.
What's 6 plus 8
14.
plus 5
19.
plus 9?
28.
What's 2 plus 8?
2 plus 8. 10.
Alright, let's see here. And what's the last one?
8,000.
Just a regular old 8,000. It turns out 8,000 is a cube number. Just like 8 is a cube, right? 2 times 2 times 2. Well, obviously, we're just adding zeros. Okay, I like it. Let's see here. And like I said, these are numbers just... these for sure you should be familiar with. Should be able to recognize a square number when you see one. Cubes a little less, but you should still be... like, I mean, that number right there should stick out, and so should that one. But anyway, those are the cubes. Like I said, just to be familiar with them, so they're not strange if you run into them on a test or SAT or something like that. Okay. And what was the other part? It was difference of two cubes, and you were gonna give me the formula.
Yeah, you told me to look at the formula.
Yeah, well, not just look it up, but yeah, we were supposed to try to create the formula after we did several of them. But anyway, tell me what it is, and let's fool around with it. So if you have... Go ahead.
You gave me x cubed minus 8 cubed.
Sure.
And you said that, well, you said that was the formula, so I looked up the formula for difference of two cubes, and it said a squared minus ab plus b squared a minus b.
One more time?
A squared minus ab plus b squared a minus b.
A squared minus AB plus
B squared
B squared
and a minus b.
multiplied times A minus B?
Yeah. And you gave me x cubed minus a cubed.
Right. So what are you going to do? So which one's A and which one's B? That's what I mean. These formulas help you out not at all when you're looking at them.
A is,
So wait a minute. Let's do the difference in cube for these. For this x squared minus... and is that 8 cubed?
You gave me x cubed minus a.
Yeah, that's not a square. It's a cube, and this is an A. But let's just go with a regular number, like I don't know, 1. What was the cubes for that? All right, what was the factors? You did it. We did them. We did this and a bunch of them.
Yeah, I'm looking back and trying to find it.
Because I have a problem with that negative right there.
You gave me x squared minus 1.
We did a whole bunch of them. We did x cubed minus 1. We did x cubed minus 8. We did x cubed minus 27. All of those. Where are they?
Where are they? That's a good question. I remember writing them down, and they are in this notebook, but we did difference of two cubes.
That's what we're doing, difference of two cubes.
Right. We didn't do x cubed minus 1 cubed.
Yes, we most certainly did. I have it on video.
We did x squared minus 1.
That's difference of two squares. We're doing difference of two cubes.
Maybe I miswrote it. No, I didn't, because I did it correct with that one. Fuck. I guess I did not write that one down.
Well, what did you write down?
I have the x squared minus 1.
That's difference of two squares. We're doing difference of two squares. Difference of two cubes.
No, I don't.
Do I need to do the lesson all over again?
No. X squared plus x plus 1, x minus 1. I just found it.
So x squared plus x plus 1 times x minus 1. Alright. What if I did, we'll change this to 8. So that was 1. What's it going to be with 8?
X squared plus 8x plus 64, x minus 8.
X squared plus what?
8x.
Are you sure? Plus what?
64.
Mm-hmm.
X minus 8.
Alright. So that was the difference. I wanted just 8, but that was 8 cubed. What if I just had 8? But wait, before I even do that. So what's that?
That's the root.
That's the cube root of 8, obviously.
Yeah.
What's that?
That's squared.
So that's 8 squared. And what's that?
It's cube root again.
Alright. So if you just memorize it that way, you can. But alright, so let's do, I want just 8. Which is, if you want to get crazy, 2 cubed. Right?
Yeah.
Alright, so if it's 2 cubed,
The x squared plus 2x.
I'll tell you that. Wait, hold on a second. We'll do this one. Can I got room? Yes, I do. We'll call this x cubed minus 8 cubed. What's 8 cubed anyway?
It's 512.
So, because probably you're not going to see 8 cubed. You're going to see x cubed minus 512. Probably they won't go that high, but anyway, alright. So now we want x cubed minus just regular old 8. And I'm going to have an x squared, then what?
X squared plus 2x
Mm-hmm.
plus 4.
Mm-hmm.
X minus 2.
There you go. Can you do the math? Let's do it. X squared times x gives me x cubed. Oops. Cubed. That's this one times that one. Then what do I have? Then I have minus 2x squared. Right? But then look, then I'm plus 2x squared, which is 0. And then I'm 4 times negative 2, which is, oops, I forgot. Did I do everybody? I didn't do everybody. Then I gotta do this, which gives me, no, I'm gonna keep going. Let's see here, negative 4x, and then I do that one, and I get positive 4x, and then finally I do that one, and I get minus 8. Well, there's a 0, and there's a 0, and what we're left with is x, oops, just leave it like that, is x cubed minus 8. See it? That's your distribution. Now you should be able to draw a picture of that. And all it is x squared plus 2x plus 4, and x cut off the 2 this way, right?
Right.
Did you draw a picture?
No, I have it written down though. Wait.
Draw the picture. There, and I'll help you. We'll draw it. And that way you wouldn't make this mistake. How is it possible that this could be negative?
I don't know, that's what the formula said online.
Oh, I know what it is. It's
the negative is a positive, so.
I know, and that's what I'm trying to figure out. If that coefficient here is going to be the opposite of that, right?
Yeah.
So anyway, all right, let's draw a picture of it. And I'll tell you what, let's just, we'll start off with a green one. Is it going to be lime green? Oh no, all my pens are in my pocket. That's okay, I've got a whole another box over here. And my pants pocket is elsewhere. Alright, so let's see here. We'll take this one. And let's see, I need a red one. Oh no, I got a red one. Got a nice green one. And the blue one. Alright, we're set. So here is my 1,000. Correct? And then I have to figure out how to put 8 in the corner, right? To cut off 8 in the corner. So what I'm going to do is I'm going to make space, and it's plus 8, and see we're staying 2D, right? Because guys that try to teach this, and I've seen Montessori teachers try to teach this in 3D, and it gets fun in 3D, but it's a little more difficult. All right, so I have no space. So here's what I need to do. I need to figure out how to get 2 in there. Remember when I did 1, I just cut 1 off, but this time I'm going to do 2 because it says 2. So I'm going to add 2, but then I'm going to take away 2. Right?
Yeah.
Oh dear, hold on a second. I need to plug this thing in. Alright, my happy charger. Or charging cable. Oh dear. That's so much stuff in plugs, it's crazy. Alright, hold on a second. You may experience some temporary discomfort. Well, there she is on my tablet. Alright, let's see here. Hi! Okay. Ugh. Guess what? It doesn't reach. Alright, so, you know what I have? I have an extension cord. What do you know? Alright, now it reaches. What do you know? Can you still see? How's that?
Yeah, why am I on top of the computer keyboard?
Because that's what I needed to set my tablet up, remember? Otherwise it wouldn't sit up.
That's true.
Alright, so, and now wait, let's plug this back in. And everybody's happy. Alright, so now, so I did that. What else I gotta do?
You gotta add 2.
I'm gonna take away 2 over there and 2 over there. So if I took away 4 of them, how many am I gonna have to take away? Or excuse me, how am I going to have to add? Because I took away 4. So I'm going to add 4. Yes, all right. 1, 2, 3, 4. What's going to fit right there?
16.
Really? Because 2 times 4 is 16?
No, sorry, 8.
Really? Oh, fine. Here's another pen. I got pens! And that'll... Oh, that's brown. Cool. I don't want brown. I want black. It's a cool color brown, though. I have a little girl that will love coming on this whiteboard, and I've got all these pens. She'll make me some kind of crazy artwork. There you go. And there it is. And once again, all I did was take my pieces and visualize, because there's all this stuff in the middle, but they're all zeros, right? And see, that's that again. Sometimes it's important to know how big your zeros are. So I just do just that. This is an x square. That's an x. and then we took away 2. And let's see here. That whole thing right here, this is an x cubed, because it's x squared by x. And then over here, this is an x and another x. And then over here, this is 4x. And then that's x minus 2 again. I just labeled everything more than I needed to, but alright. So then I have an x squared plus 2x plus... Oops. That's not 4x, it's just 4. Those are 4 x's, but that distance is just 4 right there. And there's my 2x, okay. And then it's just x minus the 2. Alright, so let's say I had... Let's pick a number off your table to make it look like it's crazy hard math. But it's not. What's a cube number in the teens? Pick one.
In the teens?
Pick one.
Cubes in the teens. 2,744.
I hate that one. Try another one.
Like, okay. Why do you hate that one?
Do the 33.
Okay, 3375.
There, I like that one. That's 15. 3, 3, 7, 5. Oh my God! Now what? So what's this gonna be? What's this gonna be over here?
That's gonna be a minus 15.
There you go. That's easy. What's this gonna be over here?
That's gonna be 225.
What do you know? What's this gonna be over here?
59.
Oh look! Said, oh, this is crazy. It's not hard. That's 15 squared. Let's put that here so you know. That's just, here's 15 to the first. Here's 15 squared. And there's 15 to the first. Or you could look at it the other way, where this is the cube root of 3375. And this is the cube root of 3375. And this is still 15 squared. Right? So basically what I did is I took the cube root and squared it.
Yeah.
Alright, so difference of 2 cubes should never be a problem ever again as long as you live.
Just gotta memorize the cubes and the squares.
Well, you know me, I hate the memorization, but yeah. But you should know your cubes and squares, yes, definitely.
Yeah.
Right, and like I said, just that number should be familiar, or vaguely familiar. When you see that, you go, 15? I mean, it ends in 5.
Mm-hmm.
Right? Alright, let's do one more just for giggles, and then we'll call it a day on this lesson on difference of 2 cubes. And then I need to see your what's it called, the syllabus or whatever that you had for this year, because we're not going, if you take a look at that syllabus, we're knocking stuff off one at a time, right? It was a pretty long list of stuff, and we're just knocking them off. What do we got? We were doing graphing. Let's see. We're graphing. Your mom sent it to me.
I don't know what it is. She didn't show it to me.
All right,
are we behind though? Are we on track?
We're a little. I'd say we're good. We're ahead of where your friends are, because I can guarantee you, many kids in your class. I mean, like I said, they get 70s and they move on, whereas you're starting to exhibit some mastery. At least you know when you screw up.
Yeah.
Whereas a lot of times those guys don't have any clue when they screw up. All right, pick another number.
5283. I mean 82. 32. 5832.
5832. What's that the cube of?
18.
Yeah. So what are all these numbers going to be?
X squared plus 18x plus 324 x minus 18.
324 because that's 18 squared. So I tell you, get those. You should know those. Right? I mean, those are ones you should. What's 6 times 6?
36.
There you go. So you should know 15 times 15 is 225, and you should know 19 times 19 is 361. Like, not even thinking about it.
Yeah.
Right? What's just for fun? Here, we'll do a quick quiz. verbal. Close that book.
Why?
Why? So that you don't just look at it's not a can I look at my book and find the answer test. This is a do you have stuff in your mind test. All right, what's 12 squared?
144.
All right, you got the first one. What's 17 squared?
Well, 18 squared is 324.
All right, so what's 17 squared? What should it end in?
196.
Not even close. How are you getting 7 times 7 is going to end in anything other than 9?
Okay, 17 squared. Let me do this in my head. 100.
Oh, good. All right, fine. I'll take it. Bam, 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 bam. Right?
Just for a second.
100, 140, 49.
189.
How much?
289.
289. Be 17 squared. All right. And see, that's the thing. Bruh, how can 7 times 7 end in 6? Oh, you're right. It can't. You're right. Okay, so what about 16 squared?
100.
See, you want to do all kinds of pre-calculus and all kind of stuff, and you still don't have your multiplication tables done.
256.
256 is correct. And see, that's another one that should be clear in your head. That's just...
Is pre-calc on my syllabus?
That's where that's all this is. What are you doing? Algebra 2? Like, you can cut it up into pre-algebra, algebra 2, and pre-calculus, but it's all one thing.
Okay.
I mean, right?
Yeah.
So basically, I would hope that by the time you get, if you're going to go back to public school, which next year or whatever, or private public school or whatever it is a lot of the stuff that they cover, it should be a gimme. It should be an ace for you because you've already seen it.
Okay.
Right? And like I said, that's what lowers your test anxiety is knowing the answer.
Mm-hmm.
But the problem with you is a lot of times you know the answer, you still have test anxiety. I give you a test on multiplication and tell you got to get it done in 5 minutes and you're going to be all panicked, even though it's just multiplication. And you know how to multiply numbers together. And guess what? If you can multiply the first 9 numbers together, you can multiply all numbers together. It's like if you can add the first 9 numbers together, you can add any 2 numbers.
Right.
Right? Same principle. If you can factor a polynomial, you can factor any polynomial. And you should be able to tell whether it's factorable or not. If you can do difference of 2 squares and difference of 2 cubes, you can do any 2 cubes. All right. Let me just finish writing that. And see, 324. All right. Oh, what's 13 squared?
That's 169.
That's easy, right? Should be.
Mm-hmm.
Right? It's not even dynamic because it's 100, 6 tens, and 9 in the corner, right?
Yeah.
All right. Okie dokie. Oh my, so much to do. So little time. What shall we do next? Okay, I'm going to turn the camera off for this one and we'll make a new video after this or something. But anyway, so there it is. Difference of 2 cubes. Easy once you know your squares and your cubes. If you've never seen squares and cubes, can you see where that would be kind of hard?
Yeah.
Right? But once you've seen your square numbers and once you've seen your cubic numbers, I can throw anything at you. And then after that, if you see it's difference of 2 cubes, right? Well, they could always have this too. If you've got a calculator, you could figure it out, right? Like let's say I had something crazy, like I don't know, like for fun. What's 25 cubed? Punch your calculator. I'm gonna expect you to do it in your head.
I was gonna say you didn't tell me to do that.
No, that's outside your range, but so what?
That's 15,625.
It's what?
15,625.
Isn't that interesting? See, numbers don't interest you; they scare you. What's 25 squared?
220. 25 squared? Oh,
See, that's another number you should know. You should know how to square numbers that end in 5. We did this lesson.
It's 625.
It is 625. Oh, gee, and it cubed, it's 15,625. Vaguely interesting. All right, so this is just 25. This is just 625, and this is just 25. Oh, look, I'm done.
Why is it 15,625?
Because when you multiply 625 525 times. And that's what you're going to get.
Okay.
And do you see the 625 there?
Yeah.
25 times 25. Well, there's that part. And then then what? Then you just get 15,000 when you multiply this 25 times.
Yeah. Okay.
Yeah, all right. So, like I said, all right. I think that lesson is done. I should put this in the beginning. Diff of two cubes. That's what we just did. Difference of two cubes. Super easy. We should probably do a lesson on Pascal's triangle, just because, but that's side work. We gotta get other stuff done. All right, so what's your homework gonna be again? Is get your multiplication tables handle.
Okay.
All right, so that when I ask you, what's I don't know, how about an easy one? What's 17 times 13?
That's 221.
Good. Excellent. Good job. What's very good, actually. And see, this is the thing. You should be able to do it pretty quickly in your head because all you're gonna do is add up those parts, right?
Right.
And dude, we're only 2 digits, and they're teens. So, all right. So let's just fool around with that. I'll keep the camera running just for fun because this is just drill for skills type stuff. What's we'll do 18, 13 times, and then we'll do like 19, 14 times just for fun. All right. So what do we got? Well, it's gonna be 100, right? 110, and 20. What's 3 times 8?
24.
There you go. Bam. How easy is that?
234.
234, right? Even went this way. 2, 3, 4. All right. And look, 2, 3, 4. 18 times 13, right? 3, 4, 5. 1, 2, 3. 2, 3, 4. All right. What's 14? All right. 100. Phone.
Hold on.
You can answer it. Do you need to answer it? Or is it a bill collector or not bill collector, telemarketer?
I'm at my nana's house anyway.
All right.
130. It's 100. 130. 200 and no 300.
Wait a second. How'd you get to 300?
Well,
I got 100. I got 130. And 4 times 9 is 36.
Yeah, I was right. And then your 160 threw me off. It's 236.
Try again.
266.
There you go. See what I mean?
Yeah.
Alright, so these, and that should be a no-brainer, don't have to think about it much, or, you know what I mean? Like, okay, I can knock it out quickly.
Mm-hmm.
Right? But I mean, it should be just 19 times 14, 266. Done.
Yeah.
Right?
Mm-hmm.
Alright. I mean, you have vocabulary of, probably you're female, so you have more vocabulary words than males, generally. You know, it's several thousand in your working vocabulary daily, and probably, I think the last time I checked my vocabulary, I was somewhere around 60,000. Alright, so that's words. And then I figured out that, yeah, at 60,000 words, I don't know what the words mean. Right? All these definitions they gave me are, I thought they meant one thing, turns out they mean another, but that's a whole other issue. But the idea being is it's thousands of words. I'm asking you for 400 math facts. Right? It's not like it's the end of the world. It's just 400 words. 400 different things. 19 times 14, the same thing is 266. Right? 10 times 10, the same thing as 100. Right? 6 times 7 is the same thing as 42. Those are synonyms. You got to look at it that way instead of, oh, is there math I have to do work? No, it means the same thing. Mm-hmm. And then as you fool around with it, let's just keep the easy ones. If I have 42, my rectangle, and one side 6, what is it? The other side has to be 7.
Right.
If I have, what did we just do? 266, and one side is 19. What's the other side have to be?
14.
Gotta be. Do I have to do all the work down here? Well, Mrs. Snagglefarts will tell you, yes, you have to or you get no credit because Common Core and blah, 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 and show your work and this and that. But if you just know it... Okay, now I'm going to turn the camera off and we'll do something else. Alright, CrewtonRamone'sHouseOfMath.com for more.